A rabbit sitting in a field is not relaxed. What it looks like from the outside, soft ears, still body, nose moving in small, quick pulses, is not rest. It is a highly active state of environmental processing that never fully switches off. The rabbit is not waiting for something to happen. It is already happening. The threat system is running. It is always running. This is the first thing that separates prey animals from predators at a neurological level. Predators have a baseline. A lion between hunts is genuinely at rest, heart rate low, muscles passive, attending to almost nothing. Prey animals don't have an equivalent state. What looks calm in a rabbit, a deer, a zebra, is closer to what a human would describe as high alert. Their nervous systems did not evolve to rest. They evolved to survive the moment rest became permanent. The architecture of the prey animal's brain reflects this. The amygdala, the structure associated with threat detection and fear response, is proportionally larger in prey species than in predators of comparable size. More of the brain's total processing is devoted to threat detection, to pattern recognition in peripheral vision, to the classification of sounds by distance and direction. A white-tailed deer can detect movement at nearly 300 degrees without turning its head. It hears frequencies that reach above and below the human range simultaneously. It processes that information continuously, in parallel, alongside everything else it is doing. What looks like a deer grazing is a deer grazing and running threat assessment at the same time. The eyes tell you something important. Prey animals have them placed on the sides of the skull. This is not aesthetic. It is a design specification written by 100 million years of being eaten. Lateral eye placement sacrifices depth perception for field coverage. The predator needs to judge distance accurately to time a strike. The prey animal needs to know the direction something is coming from before it can judge how far away it is. The trade-off has been made clearly, and it was not made in favor of seeing the world in 3 dimensions. It was made in favor of seeing more of it at once. What this means experientially, what it would feel like to inhabit that visual field, is something researchers have only recently begun to model. The prey animal does not experience a wide-angle version of human vision. The neural processing differs at every level. Prey animals have a region of the retina called the visual streak, a horizontal band of high-density receptor cells that runs across the width of the eye, optimized for detecting motion along the horizon. This is where a predator would first appear. The visual system is not arranged to take in the environment. It is arranged to detect the specific shape of the thing that wants to kill it, as early as possible, from as far away as possible. The result is something researchers describe as a perceptual world organized around threat, not a world in which threat is one input among many. A world in which everything else is background and the foreground is always the question, is something coming? There is a concept in behavioral ecology called the landscape of fear. It was developed to describe how prey animals don't simply respond to predators when they appear, they respond to the possibility of predators across every terrain they move through. Elk in Yellowstone, studied extensively following the reintroduction of wolves in 1995, were found to avoid certain valleys and creek beds not because wolves were present, but because wolves could be present. The geometry of the landscape itself triggered avoidance. Open ground with poor sight lines, dense cover that didn't allow a running exit, terrain that a predator could use. The elk were making continuous topographic calculations, moving through space not as geography, but as a probability map of death. Researchers measuring cortisol in elk populations found elevated stress hormones in animals that had not encountered a wolf in months. The mere possibility, sustained, unresolvable, ambient, was enough to keep the system running. This is chronic stress in its most literal form, not a response to a specific event, a response to a world in which the event could always be about to happen. Zebras on the Serengeti spend between 40 and 60% of their time in physical contact with other herd members. This is not affection, or not only affection. The contact is information. A tremor traveling through a body pressed against yours tells you something moved nearby. A sudden tension in the animal at your shoulder tells you something changed in the part of the visual field you can't see from where you're standing. The herd is a distributed sensory system. Each animal extends its awareness through every animal it is touching. When a predator is sighted, the information doesn't travel through sound first. It travels through the body of the herd. A ripple of muscle tension, posture change propagating outward from the animal that first detected the threat, reaching every connected body within seconds. The ones at the edges feel it before they see anything. They are already moving. The prey animal's fear response, when it finally fires, is physiologically distinct from the predator's stress response in ways that reflect the asymmetry of the encounter. A predator under stress is preparing to be fast. A prey animal under threat is preparing to be faster than something that has been optimized over millions of years, specifically to catch it. The norepinephrine surge in a prey animal at the moment of detection is among the highest recorded in vertebrate biology. The cardiovascular response is extreme. Blood is redirected from the digestive system, the immune system, the reproductive system in milliseconds. Every non-essential process shuts down completely and immediately. The body does one thing: run. What is interesting to researchers is that the prey animal, in many documented cases, does not experience this as panic. Panic implies disorganization. What happens in the flight response of a deer or an impala or a rabbit is closer to the opposite, a sudden, radical narrowing of purpose. Every system is subordinated to a single output. Researchers studying the neurochemistry of flight responses describe it as a form of clarity, not a human clarity, not a pleasant one, but a state in which the animal has never been more precisely itself. The moments after escape carry their own biology. Once a prey animal reaches safety cover, distance, a boundary the predator did not cross, something unusual happens in the nervous system. The fear chemicals begin to clear with a speed that has no equivalent in human stress response. Within minutes of reaching safety, elk heart rates drop back toward baseline. Cortisol begins to fall. The animal may begin grazing almost immediately. This is not indifference to what just happened. It is a different relationship to time. A human who nearly dies carries that experience forward. The event stays biochemically active for hours, days, sometimes longer. The prey animal's nervous system is not built for that. The predator encounter already ended. Carrying it forward would cost something the animal cannot afford because the next one could come at any moment, and the system needs to be ready. The prey animal lives almost entirely in the present tense, not as a spiritual achievement, as a survival strategy. There is a behavior observed in zebras, antelope, and several other prey species that researchers initially struggled to categorize. After a predator encounter ends, after the chase is over, the lion has broken off, the immediate threat is gone, and the animals sometimes shake. Full-body tremors, lasting between several seconds and a few minutes, move through the musculature in a wave. For a long time, this was interpreted as a motor artifact, leftover activation clearing through the body. More recent research suggests it may serve a neurological function, a physical mechanism for completing the stress cycle, allowing the nervous system to register that the threat has genuinely passed and begin the return to baseline. Trauma researchers have noted that humans often cannot do this. We override the completion signal. We stay in the threat state long after the threat is gone, unable to perform the physiological reset that prey animals do automatically. The zebra shakes and it is over. The human carries it forward, indefinitely, in a body that hasn't been told it can stop running. We study prey animals to understand predator ecology, migration patterns, population dynamics. The question of what it is like to be one of them has received less attention, partly because the methodology is difficult, partly because the conclusion is uncomfortable. To be a prey animal is to live in a world that is genuinely, continuously, correctly dangerous. Not perceived as dangerous, actually dangerous. The threat assessment running in the rabbit's nervous system is not a malfunction or an overreaction. It is an accurate read of the environment. There is something out there. There has always been something out there. The system is running constantly in the background because it should be running. We tend to look at prey animals in moments of stillness and read peace into them. The deer at the edge of the field, the rabbit sitting in the grass. What the research keeps returning to is that what we're actually looking at is something closer to vigilance, so practiced it has become invisible. Not calm, never calm,